Right, here it says to solve using substitution. We have a system of equations here. The first thing we want to do is get rid of the fractions in each of these equations. So here's how we do that. I'm just going to recopy the equations down here. To eliminate the fractions, we're going to just multiply both sides of each equation by the least common denominator of the fractions in that equation. So here I have a 2, a 3, and a 6. And so I'm going to multiply both sides of this equation here by the LCD of those three, which would be 6. Now when we do this, I'll write that as 6 over 1 since we're dealing with fractions. When we do that, I'm going to take the 6 and I'm going to distribute it through hitting both of these terms. And since I'm going to be multiplying 6 times each of these terms, I'll just go ahead and write it like that. I'm going to take 6 times x over 2, and then 6 times y over 3. And of course, what you do to one side, you have to do to the other. So 6 times 5 over 6. And the same thing happens on this one. The denominators are 5 and 4 and 10, so the least common denominator will be 20. So multiply that by 20, multiply that one by 20, and that one by 20. Now what happens? When we simplify these, we see that 2 will go into 6 3 times, so we have 3x. Here, 3 goes into 6 2 times. Bring down the minus, right? And then we have 2 times y is 2y. And over on this side, those 6's will cancel. We have just 5. In the next equation, I got 5 goes into 20 4 times, so I've got 4x. 4 goes into 25 times, so we got 5y. And here, 10 into 22 times, so we're left with 2 times 29, which would be 58. So now the system of equations looks like this. Without those fractions, it's much easier to deal with. The instructions said to solve using substitution, and we could do that. In fact, I did that in a separate video. But that's a lot more trouble than we would have to go through. If we solve using the elimination method, it's really fewer steps. So I'm going to demonstrate that in this video. If we want to use the elimination method, that means we're going to add these two equations together and have either the x term disappear or the y term disappear. And in order for that to happen, what I need to have is for this x term and this x term to be the same, except one to be positive and one to be negative. Or I could do that with the y's. Have these be the same, except one negative and one positive. So let's work on the x's. If I want to make these two things the same, ask yourself this question. What's the least common multiple of 3 and 4? It's like the least common denominator. If these were fractions and I were asking what's the least common denominator, it's the same thing, except since it's not a fraction, we just call it the least common multiple. Well, that would be 12. In other words, that's the smallest number that both 3 and 4 will divide into is 12. So what we're going to do is we want to make this a 12. Well, to make this a 12, I have to multiply it times 4. So I'll multiply that times 4. Well, what I do to one side of the equation, I have to do to the other. So I'll multiply both sides by 4. Now I want this guy to also be 12, so I need to multiply that term by 3, but I'm going to make it a negative 3 so that this one will be positive and that one will be negative. Well, if I'm going to multiply that by 3, I've got to multiply everything by 3, or rather it's a negative 3. And over here, multiply this by a negative 3. All right. Now, when I do that, I'm going to end up with 4 times 3 is 12x minus 4 times 2 is 8y is equal to 20. In the next equation, negative 3 times 4 is negative 12x, and there you go. Those are going to add up to 0 when we add them together. And this is going to, I've got minus a negative, right? Minus a negative, so that's going to be plus 15y is equal to, and 3 times 58. 3 times 58, well, 3 times 8 is 24. 3 times 5 is 15. 16, 17, so 174, but it's negative because it's a negative times a positive. All right, we're finally ready to add these two equations together. Notice that the x's are eliminate, and so they're gone. 15 minus 8 gives us 7y is equal to, and 20 minus 174 would be a negative 154. And then we just divide both of these by 7. So we got negative 154 divided by 7. And that goes evenly, actually, so we get a negative 22 out of that. So the y value of the solution is negative 22. How do we find the x value? Well, let's go back up to this version of the system of equations. I sure don't want to go back up to the original version with all the fractions. Let's go back to this version after we got rid of the fractions. In fact, that first equation here was 3x minus 2y is equal to 5. We now know that y is a negative 22. So we're going to just plug that negative 22 in place of y here to solve for x. So 3x minus 2 times a negative 22 is equal to 5. So 3x, and this is going to end up being plus 2 times 22 is 44, is equal to 5. Subtract 44 from both sides. Well, let's see, 5 minus 44 would be a negative 39. Divide both of these, both sides by 3. Get negative 39 over 3. So that makes x equal a negative 13. So there is the solution. X is negative 13, and y is negative 22.